These are electrostatics conceptual questions, and this is number 1. It says the charge on an electron, and we know that electrons are the little particles on the outside of the atom, and they move randomly, so they kind of move along this path, and they are negative, and that is the answer to number 1. For number 2, we have the nuclei of almost all elements consists of both protons and neutrons. So you'll see that there are both protons, which are positive, and neutrons, which are neutral on the inside of the atom. They say almost all elements because this element, hydrogen, does not have any neutrons, so there's no neutrons on that one. For number 3, we have the two charges, and if two charges are the same, as you see these are both positive, they tend to repel each other. The next slide will show you what happens when you have two unlike charges, so I have a proton and I have an electron. Those will actually attract each other. For number 5, the fundamental force that underlies all chemical reactions is electrical. Essentially, in any atom, you have electrons on the outside. So in the very outside of sodium, we have 1. On the outside of chlorine, we actually have 7. So I'm going to draw all those electrons, and they always like to have 8 on the outside or none on the outside. So this one actually transfers over to this atom. We call that an ionic bond, and these are electrons. So this chemical reaction making sodium chloride, which is salt, is called an ionic bond. And then another one, which is a covalent bond, would be something like methane, CH4, where they actually will share electrons. For the very next problem, this is number 6. It says electrical forces between charges are strongest when the two charges are closer together. So if I have a proton and I have an electron and they're really far apart, there's not a lot of force of attraction between the two. But if I get the two things much closer together, then I end up with a much stronger attraction between the two. Same thing happens when I have two things that are similar. So I have two positive charges. There's a very small force that's pushing out on those. But if I get them very close together, then there's a very large force that makes them want to repel from each other. For the number 7, we have an equation that we're going to use. That equation is the force between two charges is equal to K times Q1 times Q2 all over the distance between them squared, where the Q's are the value for the charge and the D is the distance between them. So the force will vary directly on the size of the charges, so you'll notice that this is on the top, so it's directly related to force, and then inversely related to distance squared because it's on the bottom. And that's how you can tell using the equation what the relationship is. For number 8, we have the same equation, and all they want us to do is we're going to double both Q's. When I put a 2 in for each Q, what happens is my force then is proportional to 4 over the distance squared. So the force will actually quadruple because that 4 is on the top. In the next question, number 9, we have something similar happen. We change the equation again, but this time we're going to half the force. So this force becomes 0.5. When it becomes 0.5, 1 over 0.5 is equal to 4, so we know that that force again will go up by 4, so we say it quadruples. The very last one, which is number 10, the net charge on a non-ionized. Non-ionized means that it has the same number of protons and electrons. So this atom, which is number 7 on the periodic table, and you'll see that number 7 is nitrogen, has 7 protons and 7 electrons, so it doesn't have a charge. If this nitrogen had only 6 electrons, it would then have a +1 charge. If it had 8 electrons, it would have a -1 charge because it has too many or not enough electrons. And that's the end of number 1 through number 10.